Okay, so we're going to graph some functions by deciding whether the graph opens up or down, find the vertex, axis of symmetry, and any intercepts. So number 40, we see that a equals 1, which is positive, so we know it opens up. The vertex we can find by saying h equals negative b over 2a. So notice that's the front part of the quadratic formula. It's not like you're learning something brand new. So you have negative b is 6 over 2a, so negative 3. So then f of negative 3 is going to give you the y-coordinate of the vertex. So it looks like it's 0. So the vertex is negative 3, 0. And then that's the only x-intercept, right? Because b squared minus 4ac is 36 minus 4 times 9 is 36, so equals 0. So there's only one x-intercept. So then the y-intercept we find by doing f of 0, which is going to be 9. So the point 0, 9 will be on the parabola. Well, you also will get the mirror image point if you go 3 to the right and up 9. Then if you go 3 to the left, you would also need to go up 9. So the point negative 6, 9 would also have to be on this parabola because you have to have symmetry. And then the axis of symmetry is going to be x equals negative 3. So the domain and range, the domain of every parabola is always going to be real numbers, all real numbers. The range goes from 0 and continues upward forever. And then where is it increasing and decreasing? It's increasing on the interval where x is greater than 0, and f is decreasing on the interval where x values are negative, from negative infinity up to 0. Okay, so here we have find a quadratic function given its vertex and one other point. So here's the vertex. So far we can write f of x equals a times x minus 1 quantity squared minus 3, because we know the h and the k. The only thing we don't know is the a, but we're given one other point. So this point says that f of 3 equals 5. So I'm going to say f of 3 equals a times 3 minus 1 quantity squared minus 3, and that has to equal 5. So 4a has to equal 8, so a has to equal 2. So my equation is 2 times x minus 1 quantity squared minus 3. This is the equation of the quadratic function that draws that parabola. And you can check, because if you go over to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8, then if you go over to the left 2, you should also get up to the same point. So negative 1, 5 should also make your equation true. So you could check that and make sure that it works. Okay, and then we'll do this one together in class. Objective 5 is talking about the max and mins. So because parabolas describe lots and lots of real-life things, make sure you're clear on the difference between if a parabola opens upward, then the quadratic function that defines it has a minimum, whatever it's describing. If a parabola opens downward, then the quadratic function has a maximum. So make sure you're clear about the difference between the maximum point. So this is the maximum point, the highest value the function gets to. And this is the x value at which it happens. So a point has two coordinates. So if you're asked for the maximum point, it needs 2 coordinates, hk. If you're asked for the maximum value of the function, they're just asking you for the k. So decide whether this function has a max or a min. This has a is -2, which is less than 0. So it opens downward, and that means it has a max. And the h value is -b over 2a. So -b is 12 over 2 times a is -2. So it looks like we get +3. So the x value at which it occurs is 3. The max value happens when x is 3. Then the max value of the function is f of 3. So you're going to put 3 into the function and get 18. So this is the max value of the function. And then the max point is 3, 18. And we'll look at the picture to make sure and verify. Okay, and then here's an example of an application. This is a business application, so we'll look at this one in class together.